All right, so am I on? Yep. So otherwise, recording will be practically empty. So yes, but the first part is okay. So now you can see here our table of contents now. Getting the contents, you can see here the leadings. I try to stuck it inside each of the lecture days. So what happened to Milo? Maybe a little bit early. Haven't woke it up yet. So, and you can see the tutorials now are coming. So today we'll work on the Oculus further, but Oculus and inside Unity. So you will see a project that we prepare for you is vast resources. You can copy and paste, you can use different parts, but the key here, you have to understand the code. A little bit understand of what it does. So otherwise you wouldn't know what to copy. Okay. So you can see here the leading is usually stuck behind. So today paper is on Ron Azuma. I used to intern for him. So now I think he used to be with Nokia, but I think he now with some other company in Silicon Valley. So he's more or less the very pioneer, really top that the AR research early works. So his paper is actually very old, but it's actually one of the highest cited paper, okay, in the field, because he laid foundation of what AR is that nowadays we come to know for. A lot of terms is come from his paper. And okay, so the leadings, so the tutorial now, I think I spent updating the contents for the Oculus, so I think you will go through this inside today. Okay, so that would be a lot of fun this afternoon. So any problem on Milo's side per se? Okay, everything is access. Okay. All right, so by now everyone should get a notification email. I should set up for that. So again, just go here, click your icon, go to notification, and so you won't get missed it. Where can I find the CIA for it's in the assignments. So you see here, if you click the assignments, I think your frame is slightly different, okay? But it should look similar. For example, if I pretend to be students, I can log in as student. And then I can go in and try to look at assignments. So I go here. That's the CIA. Yes, so that's just in there. So it should be built inside it. Okay, so that's what I was saying before. When I marked it, I'll be just marking point. Okay. One thing about CIA, the way Milo struck is that the HD is always at 100%. So what that means is that usually if people fall in HD, I need to mark them between 80 to 100%. But for others, this is at the minimum. So this is 70% distinction. So this could be higher. And this is at 60%. That's the way, somehow the odd way that Milo on Rubik on Milo's works, which it doesn't make sense. If you put a HD consistent with the rest with 80% minimum, then the whole thing was calculated based not on 100% as a total, it's based on 80% as total, which is, I think, is a big flaw inside the system. But I checked with all my colleagues. Apparently, they're willing to put up with that, so I have no complaints. So just in case. So that means that when I mark it here, if I need to change the score, then I'll change the score within the band. But as I said before, the part that was difficult is going to be the comments itself. Okay, so comments itself that actually really detailed comments. So that's going to be very hard to get within the time frame we have. But as I say, if you have any questions on particular assignments, just feel free to send me. I think I noticed a few emails yesterday I haven't got to. I'll try to get to that during my break, so about 4 hours from now. I'll try to get to that. All right, so I think it's all good. So this is, I forgot to introduce myself a little bit after 2 days. So myself is originally from Thailand. Okay, I did my postgraduate in Cal Poly, so California State, in master degree. All my degrees in digital signal processing. Okay, so I don't have any programming background. I just basically engineering trained. Okay, in PhD, I did a PhD at University of Washington in Seattle. I did the work for Office of Naval Research, building a head tracking system for military pilot. Cockpit pilot. So I think you can look up my work. So this is my Google Scholar profile. Okay, so mine looks a little bit, there's no face. Okay, so but you can search me on this Google. So this is almost my paper. If you search by years, and you will see most recent paper. You can go if you like to look at some of this paper. I have a copy for you. But most of the work here is actually published online, so you should be able to get that. And then, you can sort it by citations and by patents and things like that. So you can see those are mostly, the top one is from my PhD work. So used to earn me some small money, but now no longer. Now, actually, I don't think it's secret now. It's my patent is one of the one that Magic Leaf. Have you heard of that? Magic Leaf, big startup companies, they got license for, but they got ton of license. So it's just one of those patents that they acquire from the university. So, but I haven't got any patent here at the UTAS. So maybe some of you could help me. All right. So I think you can look for those. This is a Google Scholar. If you're really interested in a post. Beyond this unit and try to look for those papers. Just try to look for Google Scholar and then search terms and the paper will come up. But writing paper in that is a good practice, but it's not a requirement in this unit. Okay, so because if that requirement, one paper could take you the whole unit to write, if you're lucky. So that means I will just make sure that the writing is just in a more formal form as much as you can. Okay. And okay, so now we can hear. So I checked with some of you yesterday experience. So hopefully, I think we got a lot of collaboration from ITS. So now I have a magic password and Lindsay. Anything to require manual update, then I just come to either of us and I will get you through it to the system. So now I think we're a lot of problems solved. So now I think we just need to cover for today and tomorrow, including tutorial, to make sure you have the base for that. On the weekends, you can start thinking about the project that you might do for assignment 2, which is the high awkward to talk about assignment 2 when assignment 1 is you haven't submitted as a full submission, so, but it's due tomorrow night, so make sure that. But it probably got to be thinking about that now, because by the time you finish tomorrow, assuming there's no need to wait until midnight tomorrow to submit, you can submit anytime. That you have to move along and then try to pick the device that you're going to be doing. So that's why we try to give you can use the RIF, but since we have 6 of them, it may not be a good idea to do all project about the RIF because you have a problem with getting the RIF to your hands. Yeah, so that's why tomorrow we're going to introduce more on easy to use, more accessible using webcam like Vuforia. I think some of you might have known. So more or less in augmented reality, and then we have 6 pixel phone that we can distribute around for AR project. For other devices I've been telling you are actually going to be rolling out in the next week. So it's more or less exposure for you. Okay, but for some of you that really want to get on those devices, the new gear that I talk about that I haven't rolled out the tutorial, talk to me and then I'll be able to. If you're comfortable enough to go by yourself, then that's okay for the assignment 2. As you know, we have plenty of devices that we just don't have enough time to roll the tutorial before you actually start working on assignment 2. Okay. Right, today is basically, first part of it is to talk about AR. Okay. Second part of it is we talk about the design process, which is actually some of you will find it's actually more it's less technical. It's allow you to kind of think a little bit more, use your imaginations, and it just provide a framework. So we'll do that in the second half. So for the AR here, just like yesterday, we go to a very simple basic about what AR is. Okay, so I assume most people have some idea what AR is. Right, so some augmented reality, Pokemon Go, that's probably the best bet. Yeah, Pokemon Go. I think you've probably seen some of them. Sorry? A cat place. What's that?
It's also an AR application.
What's the name?
IKEA.
IKEA. Oh, yes. IKEA is a popular one. IKEA is a furniture store, right? Basically, it's come up with apps that actually can put the furniture inside your living room. Mm-hmm. Actually, you can download into our apps and then you can play. I mean, most of your phone will probably work by now. Yeah, work with that. So this is our generic diagrams. Okay, so yesterday we kind of brushed through this in 50 minutes in the VR. So now we're going to do a similar thing with AR. Okay, it's just to prep you in that space. So in this case here, you practically sit inside the real world just like you are now. Yeah, and then you have computer layers in front of you that you see through them. So in this case, it's a metaphor for C2 glasses or C2 displays or projection displays and those kind of things. Okay, so you can see the real world now is coming to him, and basically passing to the computer layers. So either to a webcam, to generally what typical AI is using webcam to capture the real world instead of you seeing the real world directly. Okay, but for the HoloLens or the other type of see-through device, then that's different. That's you actually see the real world directly. Okay, so that's this. This is a classic AR system, which is a user camera base. So you might not see that well. It's a camera just right in front of her display, just a little single dot here. This is what just that dot there. Okay. That's a camera. So this is what we used to call before all this big company invest billions of dollars in building the hardware. We're the one that building it. So this is my colleagues. So usually we call them duct tape prototype. So it's usually a lot of duct tape, try to glue them together. And we're hoping the calibration will work well, but oftentimes it's not. So basically you will see this odd looking. Yes, so this is probably the best looking because it's dressed for the photo. Usually it's the hang thing and everything. And this is mostly, so she really not seeing the real world by her eyes, but she's just seeing the image that's captured by the camera. Just like your phone working now, so capture the camera there. So this is what we call a video see-through display, AR, okay, which is you see through the video feed. Okay. And that is what we came to this AR mode. There are two classical modes. Okay, so one is actually called optical see-through. This one is actually human haze. You can see the real world in yellow lines that come straight to this some kind of optical. Oftentimes you see, just think of it as like sunglasses. Okay, HoloLens is the same build. It's basically sunglasses. You see through them, and the way they do the overlay is they have the projection come from the sides. That actually, you probably look at it now. So it's come and reflected on this one and come into your eyes. So essentially, you have two light sources, but they combine it optically on that optical scanner. Okay, so so you can combine that. So this is typically the hardest thing to do because usually you observe the real world directly, okay? So basically, if there are any, because AR is rely on thing to align itself, okay? So align a virtual object. I want to put something on the top of my coffee cup. Then basically, my own eye is actually see this is a real world, it's a coffee cup, right? So therefore, my own eye is seeing this, but I want to put a character on top of the cup. What that means is that if there's any latency in my system or inaccuracy, if I move my cup, my character still might be floating here or might be floating somewhere else, and you can easily see. So that's a technical more challenge. And also, another thing is also to deal with the brightness of the display. Because the real world here, in here is fine, but in the normal cases, you will see that actually this is very bright, especially in military. You will see very bright. Sometimes they'll fly their plane up into the sky, onto the sun and things like that, and then basically that display, the virtual display combined here disappear. Just like you put up your phone, walk into the sun, you have to find your optimal angle to really see them, or you put your hands up to create a shadow. Otherwise, you wouldn't see them directly. Okay, so this is a yep. Yeah, Google Glass. It's not the reason Google Glass didn't take off, but yes, that's the same form factor as Google Glass. Google Glass would consider that. But Google Glass really technically, is not an AR device. It's a head-up display. It's basically something that puts something always constantly there. But it never really have ability to put virtual content in the real world. So you can't put a Google Glass and have virtual character on my cup and move around. But you can put virtual character always constantly on your field of view. And that's why that was technically a little bit misleading. But there's a lot of terms that people try to make it up. Yeah, but this is one of those, so that's why this is primarily used as optical. You know why the people tend to use for military? Why military try to use this system ever since its beginning, even though they know technically it's more difficult. Not just because they have $1 billion to spend. It's a spatial awareness. Because if you put on and look through the camera, essentially you're looking to a tank, just like you're inside a tank. And you have no chance. You don't want to stick your head out of the tank and then look around because then you might be the target yourself. So basically you have no choice, but you have to look for this. So what that means that you no longer see a lot of things in your peripheral view. So that means this one is actually designed so that actually your normal eyesight is still intact. Yeah, your spatial awareness, everything is still in there. And then now just have to work out the technical component, how to get the overlay to you. even though it still remains a challenge. Okay. The other one, the more simpler but it's more applicable for most of the academic duct tape prototype people like me. Basically, this is more practical. So in that case, is that you just simply have a small display, okay, it's just attached to you, and it's just like that lady with the Japanese character, and then it has a camera just right in front of it. If you're lucky, some other time the camera is somewhere else. And then basically you just look at the live feed of the video, and that's become your real world. This one is much easier in the sense that actually it's much easier to build. There's no requirement of sophisticated optics. Okay, before you require optics mean Oculus Rift is actually built off the optics. Okay, you see that two lens inside. That's actually what creates a 100-degree field of view. The actual display is like that. They're that small. Okay, so that's what I think is optic design is very key for that. But in the optical see-through, like the previous condition, it's extremely difficult to do that. Even HoloLens, the state of the art now, you can only get probably 40% of what you see in the Oculus. Oculus, you have about 110-degree field of view. In the HoloLens, you probably have no more than 40. So you will see a much smaller field of view in front of you. So that's the difficult part. So that's why most academic, until before the last few years, had been kind of stick to this one, video see-through, which is much easier to do. And this is what the basis for our Vuforia in the AR tutorial for tomorrow, which is use a webcam and looking around, and use a webcam on your laptop or on a webcam on the top of the computer, and that's it. That's what we can use AR. Yep, question?
Yes. So in this type means that must be a glass or a lens in here because it usually
You mean this one? Yeah. When they say monitor, it doesn't mean physically monitor. It's just a micro display. It's one of those small display. Nowadays, become legacy now because it's not very effective. So they're very tiny and not very clear. And so nowadays, people, the challenge is that people is actually able now to actually go after this model. It used to be a very holy grail, and then you have to get some of these devices very good. But usually it costs a lot of money. Yes. So now even HoloLens is very expensive, $4,500, but this is in the order of $50,000. And even that, your field of view is shrink. And the weight is like 2 kilos. You put your head. It's very heavy. Yes. There was a lot of fun at the conference I've been to last week when they were looking at how to use in AR in the forestry. Okay, they will make fun of some of the device that try to compete with HoloLens. HoloLens is comfortable enough. Yes, so, but you probably don't want to run with it or anything with that. But it's not that heavy. Some of the competitors that try to beat is 1.5 kilo. And you know what effect is that when you put 1.5 kilo on your head? And not just because your neck will get pain, but actually turning become non-stop motion. You imagine you have a big head and you try to turn. The problem now is not turning, it's stopping from turning because the whole thing would have inertial moment. So you would go, ooh, ooh, and then you come back. So eventually I think it would, basically it's a universally disapprove that device, so I didn't really take off. But it backed up by a big company that tried to get a piece of this business. So that's why all of these configurations just give you a sense. So in this class, in tutorials, you expose both of them. Most optical see-through, the only one we have is a HoloLens. Okay, so we have 2 of them, so you get the feel for it. But most of the practical one that you can use is a webcam to the Vuforia library that I talk about, which we will do it tomorrow, and also with the phone. Phone will be a video see-through mode as well. So you actually don't actually have to stab it, you just look at them. Okay. So these are some of the things. This is no longer available. This is in museum. If you have a museum, so you will have this, a lot of these. My colleague the other day, I still have to post that image for you next week. He has about a stack of them. It's about, not this type, but he has many, ever since, because he's been in design HMD, head-mount display for 20 years. So he has like almost 100 collection. And good thing that he actually take a picture, so thank you, I'll grab it. I'll use it in my class. So some of these is a legacy. Okay, so this one is a head mount, is head display, has a micro display, and this is, I think is OLED. That one is military grade. Okay, that one is expensive. It has a little bit of weird looking camera in the front. This one is actually have the camera where the eye is, because one of the problems with video see-through is a misalignment between where the camera is, because with the duct tape, sometimes you might not get where your eye is supposed to be. And what happens if you actually have a camera up here? You're always going to be interacting as if you're actually much taller, when in fact your head is like a bit this far. So that's a calibration process inside you when you build it. So that's what attempt to try to eliminate those, so to have this eye looking just like up front. Yeah. I remember that one, the 20,000. Yes, so just that one. It's only certain entity can afford some of these. Okay. So generally, these people make money by selling contract to military, to those kind of things, so they get a bulk of this and try to make a. But AR has been around since the 60s. Okay, so this is way back, many years ago. But it's really take off in the wide public space when this kind of library came out. You might have seen, if you're actually about 10 years younger, you might have noticed this is one of the popular toolkits. It's a software library. It's written in C. Okay, so you can download that. And basically, I think it's still available. So this one is actually my colleagues. If you remember, Professor Mark Billinghurst, he's made his first name from this one. Okay, so he is and Professor Kato in Japan. It's actually built them together. Dr. Kato built computer vision that based on this using camera. Mark is actually built the interface, how to use that tool in the AR sense. Okay, very successful. They won many awards. And this one become most widely used technology from, I think the first time was 1999. They've been using for at least 10 years before Vuforia is the one that kicked them off, kicked them to the side because they are much more algorithm-wise. It's more complex and more complete. So this one becomes you need a lot of marker. So you read the paper, you go read the AR paper. You will see all this paper from 2007, 6 early on. It all has all this VR-looking marker attached to all the workplace everywhere. Yeah, so you will see that it's a much, it's easy to use and very much allow other people to get in. Like yourself will find it's very easy. So, but Vuforia is a little bit introduced a bit more of a feature that actually, instead of marker that has a black square, okay, thick border, which is part of algorithm requirements. You actually have a pattern. You could have a picture of people's face or anything. In that case, that you allow you to build your marker here, which could be visually pollution for what you're seeing, because you just want to see your workspace, but all you see is really all this marker. Vuforia allow you to turn this marker, still require marker then. This is Vuforia's first time came about, I think it's 2008, yeah, so about 10 years ago. They still require marker, but the marker pattern is flexible. You can retrain your marker. So it could make more like an image, photos, or those kind of things. So I think that is what changing a lot of this. And then I think this is really what, in the scheme of things, this is a taxonomy in terms of what AR augmented reality views will look like. Okay, so you can see your eyes is on the top left. Okay, so. So the one that next to your eyes, so that's a type of display. So you go this horizontal here. So you see this is attached. So that is mostly a head mount display. Okay, body attached. This is actually not necessarily attached to the head. Okay, so this could be a projection base, and this one is spatial. So this one is where you actually mount it in the physical space. Okay, that's where this is diagram taxonomy. Just give you a sense that actually there's multiple ways in which you can create an augmented layer. Okay, just to put the task is just to put a virtual character in my cup. There could be many ways to do it, not just via headset. Yeah, it could be a mobile device, could be a projection display. If I calibrate that, I could put this up on the top, and you might see a character dancing here. Yes, of course you do need a camera there to capture what I see. Okay. So there's quite a few things here. So very close to you is a head mount display. Okay, so in that case, as I said, there are two terms. There's a different head mount display, HMD. Okay, so this is something to mount to your head. Not really, you wear head worn display. Okay, head up display is something that's floating, that's kind of fixed in space. Okay, that could be, you can think about When you are running, you could have a speed, have a car speed. When you're actually driving a car, it's very fixed on your windshield. That's kind of head-up display. Okay, that's head-up display, the HUD. Okay, head-mount display is something that actually interact with how your head is moving. If your head move here, character should either do something spatially reacting to how you move. Even though you put a character here on my coffee cup here, if I move my head, it appears to do nothing. When in fact, it's actually do everything, try to keep the character there. Head-up display, on the other hand, don't do anything. If you have the character wheel here, if I move my head, it will just come with my head. It doesn't interact anything, it's just fixed in space. Yeah, so head-up display is a lot. Head-mount display is quite a lot of work. You have require a lot of tracking to do that well. For the body attached here, sometimes you can have a handheld device, so that's now become a mobile device. Okay. Used to be mobile device is really, iPhone is really the one that tip all the things that going this way that we have now. Before that was Nokia. They are kind of not that powerful, like 10 years ago. So handheld in the past is considered a very small computer with a webcam. It's weighed about 1 kilo, and you hold it with one hand, try to hold it with one hand. It's essentially, it's called UMPC, I think, Ultra Mobile PC, which is no longer will have that, and you have iPad and everything, so replace that. So essentially, it's a computer. It's not a mobile device sometimes. That's why the term is that give you a sense that it's actually a handheld display. Okay, so that's a mobile device. Handheld projector, that's an interesting one. I will have the video showing to you. So you have a Pico projector, which is a small projector, not a big projector like this. It's a very small one that you can wear, okay, that you can wear and project in front of you. Okay. And as I said before, the last one here is special. This one is actually, you can have projector, multiple projector to align here. If you have multiple projector here, you have alignment of software. You can turn this wall, make this wall, this door, and the corner of that disappear. Because essentially you can paint them so that it's actually seamlessly in one surface. Okay, but that's require a lot of work, though, technically. So, but yeah, once we get to that part, then you will see. So this is a bit of a history. Okay, so this is the first time, I would say, most academic would know what AI is. That is Professor Sutherland. He's now in 1890s. Okay, he still show up at the conference sometime. He's a big in optical display design. Okay, so you can probably remember that this one is actually optical tracking. Okay, and this is what he wearing here is a mechanical shaft tracking system, which is in the 60s. That's the only thing they can afford. They have available for them. So essentially, the way they track their head is by that shaft that attached to the ceiling. It's a mechanical arm. It comes just like, it's basically stretched and detract and things like that according to your head movement. So this one will have much more severe when you run off trying to run, because this one is mechanical. It will really definitely pull your head off. And he has a two-piece stereo. So this is really considered very futuristic. Of course, it didn't go anywhere. It's a research paper. It's inside university. But this, you can see a lot of these features. Actually, that's what we're achieving, just about achieving today. So that's this is like 40 years, 50 years ahead of his time. Yeah, so, and this one is interaction device, not a microphone. He's not doing a karaoke or anything. So he's just basically holding a tracking device. So in that case, it's a virtual pen. So he's just looking through something to his two eyepiece, and he tried to interact with a virtual object. Very simple, very few polygons. He was doing that. But this kind of system take years to build and take a lot of vision to try to get here. Because it doesn't look like much. It doesn't look like you do anything. In fact, it does really actually never really do anything useful, except that it's actually project the vision. Yeah, so this is a kind of a quite impressive work. Okay. He from MIT. Mm-hmm. And this is my supervisor. He's Tom Furness. At the same time as Sutherland is going in academic, Tom Furness is going in military. Okay, he started off with this. This is him when he's much younger. Okay, with no beard. Okay, and basically he go and then he really focus on the head-mount display design. Okay, so what the military for, and that's what his conceptual on the left. How he thinks what is right now. This is what militaries are using, but this is really what they were planning many years ago. It's about how to use the headset instead of everything go to console. Here, we're only talking about his situation is about cockpit, fighter cockpit pilot. So very small, very critical, moving very fast. You have to make decisions in a split second. So this is how he planned that, okay, the device should look like, not should look like this, but this is a research prototype. Okay, it should, how is it control different object, missiles and everything. Before missile, smart bullet, I think, it's actually, you have to line your plane behind them, like World War II. You have to line up your plane to the back of the plane so that you can shoot straight, because that's the only way you can shoot. Right? So now they were talking about smart bullet here, but how would you engage with a smart bullet, smart missile? So how will you actually tell them, okay, you shoot there, before satellite, everything that we have nowadays. So they were talking about use their head to aim the target. I mean, some of these is really quite, nobody heard of that before. So I mean, you don't actually have to turn the plane. You can just look and you just click, and then because on your display we have a mark that actually highlight there. But how to get from that mark that he see to translate into the machine, that's, I mean, the cost is significant if you missed it. But nowadays with the technology, smartphone, this is really kind of given. This is practically it sits inside the airplane now. Okay, not a commercial one, but. And that was in 60. As you can see here, 60 is really emerging in the field, just the same thing with everything else. It basically stays within a small group, okay, that has money to drive it, okay, when the rest of the world are either not aware or doesn't care, okay. And then it moved a little bit into the more commercial, try to see, this is more in the early 90s. This is at Boeing, start to, okay, maybe this is a collaboration with university. They try to say, maybe AI might be useful. When in fact, this diagram is look really old, but it actually, this is what automobiles try to achieve today. Okay, so what that does is that the problem that happened here is that manufacturing tried to the plane that you get on is actually need to require to really long wide cable and everything. Okay, and basically, if they make a mistake, that means they could be set them back for months. Okay. So what that means is that they were looking for technology to help them increase the efficiency of their progress. So right now they just basically just don't have a way to do that at that time. So they will see, okay, maybe if you have AR device, okay, in the image in the middle here, and basically all the manual and thing, they can tell you exactly, like Iron Man tell you exactly where this thing's supposed to go, what's supposed to go here, which color of the wire is supposed to go here, and to go from this position to where, it's supposed to tell you those. Of course, we are not that quite there, even though this is 30 years, almost 30 years now. Yeah, but this is the kind of concept at that time that what AI would start to interest to industry, big industry, not small one. Yeah, it's a big one like Boeing, that has a muscle. And this one on the top on the right, the top right here, okay. This one is another group in the University of North Carolina, Chapel Hill, UNC. That one is actually a big research group. That's what Ron Azuma, the paper that I put it in the reading, he's actually a PhD student graduate from there. So this is a big group at that time, 20 years, get multiple $1 million to do an ultrasound project, which is one of their subgroup is to look at how to visualize the data you have. So in this case is that how to actually see like Superman vision, to be able to see through the surface of surgery before you actually do them. So that's with just their prototype at that time. So the patient's hands is looking at the body, they're about to make the cut, the surgery. So they have the scan and everything beforehand, ultrasound, CT, MRI. So how would you actually get there and then allow them, instead you look at chart, planning, and save and go and do that, all right? So this one is actually allow you to see through, because that was the concept of projecting, okay? And you can see here, they start to kind of getting real more diverse application 20 years later on after it's first introduced, okay? But as you know, this thing is really not happening. Like this one, 20 years forward, now is replaced by micro precision machine. So that means, just like I said the other day, Da Vinci's machine, $1 million machine, so that allow you to surgeon to actually control with a precise mechanical arm. So some many things. So and then also in the mid-90s here, things got into the commercial. Okay, so that's some of the groups that start to come out as well, because AR would not, at that time, not associated with mobile device, mobile computing, mobile portable, okay, because the whole AR system are usually half of this table, so it's not really built for move. So, but this group is our MIT, so wearable computing group that still exists today, but probably not as young as that. So they're actually specialized in this, computing, wearable computing. There are a lot of them actually work for Apple. So that means that they're actually driving this business in this portable, smartwatch, some of those and things. But at that time, it's just very, very look like cyborg type. You have a glass, and I think they may. I think one of their internal funny competition is that who can wear this one the longest. I think like we never take off. I'm not sure about taking shower or anything, but I think that's one of them they go after. Because that's one of the key. I mean, wearables. And this one is actually inspire a lot of many works nowadays about clothing. I mean, right now you start to get shoes, you start to get this that has a small sensor, and the fabric, if you look hard enough, you will see a lot of them in fashionable ways. So your clothes now can touch and can have something there. The issue with that, can you watch it without the battery damage, things like that. So those are quite different, but those are kind of born out of computing now become wearable computing. So, okay, so sport, driving, health, and things like that now it used to be drive force for all this. This one you're probably familiar with American football somewhat. Okay, so the yellow line is an AR line. Okay, so it's not real. Okay, the yellow line. So that. If you don't know about the rules, so essentially the opposition is supposed to carry the ball somehow, okay, to pass that line to continue to play. Okay, so that means that yellow line is always moving forward, moving one way. Okay, because that's what your goal is, to drive that one into the end zone on the other side and score. Okay, so I mean the yellow line is always going to move. Unlike the white line. White line is a chalk. It's actually the actual paint on the floor. The yellow line is the one that give the audience watching on TV to know that where the game play. What they used to do, or still do, is that little triangle pole, red pole, just right on the top of the screen. That's when the linemen keep moving. It's moving this as the gameplay progress. This guy will moving around, and then put it there. But that yellow line is help the audience at home to actually see it where they are. Okay, because when they watch it, they just barely see that. So that line is actually quite good. So this one AI is done with a commercial grade on televised television camera. Okay, so you have a professional broadcast camera, sit on the stadium, multiple of them. So they have to know which direction they were looking. So that's what AI was calibrated just for that. Okay. This is the first commercial, I would say, success, okay, for the AI. Okay. Nobody really knows that that's the AI. It's just there. That's a lie. But the thing is, people now believe the lie exists. They think, oh, okay, yeah, well, that's that one in replay. The trick for this one is really how would the yellow line is not cut across this person's legs. If you have overlay, you should just chop it, right? So that's one of the things that actually post-processing, but the key for real-time broadcasting is a real-time processing. They have to have this within a small amount, fraction of a second, to be able to get this right. Okay. Otherwise, we just look alive passing somebody ahead. It's probably nobody like that. Yeah, so. But this is done for calibration beforehand, so they know exactly what the field look like, and they know exactly this is an image segmentation. So they remember this mid-90s. It's not really a real-time segmentation to really run at that resolution. So they have to go to quite a bit of development technical, try to make this thing actually sufficiently good enough. Okay. So, but that is actually a very good example. As a camera is panning, that line is actually not moving. It's just got to stay at the same where it appears to be the physical location of it. Otherwise, the whole thing was off. And it won't work. Okay. And that's what the AI is. Okay. Yes. So this is quite impressive. I think nowadays they move this into a more of a commercial use. If you see some of the live broadcasts now, some of them actually have advertisement. They're changing. If you actually, it's not real. It's actually something that's superimposed on top of it. Okay. Yeah. So some of these, it's probably give you an idea, okay, before you're about to hit what the state of the art today, okay, in our tutorial. Then you will see that, okay, this is a long way. It's not just pop up yesterday, and you will get to use it. This is a long history of things. Hopefully you appreciate a little bit more when you read the paper. You can look at some of these. So like assignment 1, assignment 2, 3. You don't have to work on a new idea. You can refine the old idea that people have done. It's perfectly fine. Okay. But remember, you have to cite them. You have to cite them. You not say, okay, this is my own idea, and then I look, this look very familiar. Yes, so that's why I think it's get good. So you can get the stage here. So this is a follow typical trend of a technology. Okay, heard something about Gartner hype chart. That would just technology inception, go exception, and then exaggerate expectation when people think, oh, VR will solve the world. People will get a lot of stock, a lot of people invest in the project, and then when people realize at the very top expectation, people realize, oh no, VR is not going to solve the world. Then people will start to kind of leaving the ship, so people are no longer interested. But usually, if you're not coming back with expectation, I mean you're dead. The whole technology will be gone. So what that means is that you have to find killer apps to sustain that curve. So that when you're going to drop no matter what, like VR here is dropping at the moment with the peak. Yeah. But the thing is there's a lot of devices and everything out there. So now there's a lot of useful apps that are actually useful for VR. So I mean this could have potential to sustain itself for the longer period. Okay. AR is still not hitting there. AR is still up in the high, but I think it's coming down slightly. Yeah. Yep, so with this AR here is that the whole thing is building. We use the word term experience a lot, okay, even though a lot of things are really task-driven. But experience and traffic and task itself is actually more or less the same thing, but different side of the coins. Okay, so basically experience is that how people are using it. But how are people going to use, how they're going to feel, it really depends on what they actually try to achieve. If that's happiness depends on they complete their task, then of course that task requirement becomes that part of their experience. So essentially that's why I use this term quite casually, interchangeably. Okay. So this time is a pyramid without the top. So basically the base here is a component, which is what you are kind of exposed to inside tutorial. All the tools, the kits, and the library, software, Unities, and those things. Thanks to Unity, those components are much simpler to deal with. You just deal with one platform, and the rest is just doing an add-on, plug-in Unity package of different device specific. Okay. And now you're moving along in this line. Oh, no. So you get the tool that you can build. Okay. And now the tool here is actually component here is a technology. Tool here is getting more or less what you can do with it. Right, so that would be generally the SDK that people build. Like Oculus will build SDK so people can interact. They can create a native app to interacting with it, or they can create a plugin. That's why most of the companies now, whatever the device they come in, they have to build in a Unity package for it, so people can actually load into their Unity one. Application here is what you actually build. Okay, where to actually build what is for. So now you have the tool. I show you, for example, yesterday we have Oculus. Oculus used inside Unity platform, but what do you use it for? And that's become big question marks. What the killer apps, application, what you try to do. Okay, experience is set on top of that. So what that means is people acceptance, user acceptance will be the key for what experience to come. Okay, so that's why this diagram, the purpose of this diagram is to give you a building block. You can't just come, okay, I want to build something cool, because essentially you'll be just focused on the top. What do you mean by cool? Then you start to break it down, so you will come down to the fact that you actually have to understand enough of the component. That's why this unit is really not about building the component, about understanding what components can be, and then build and try to use the minimal tool that we have for you and limited time that you have, try to build them and then project it really could be comprehensively in the writing, which should focus around what the use of application is. That's why you should pay attention when you write the assignments. This is about those ideas that sit inside the report. Okay. Experience here is the one. I would suggest that if you're really into a UX, which is short for user experience, you follow someone like Disney Research or Imagineering. So that's a big company, the one that's driving this all the rise, design, and build of Disney World, Disneyland. Okay. They're actually very expert in this area. They merge between technology and get to the experience. Okay. The term that you could be confused a lot of time is a user interface, which is a UI, and then the UX, the user experience. The key here is that user experience are really aimed for if you are happy if you actually see the experience. Okay, just like Disneyland, if you think about that. Yeah, you go there, regardless of how many million of people were there with you at the one time, busy getting into the line. So But that is actually experience that you take out. User interface about whether you can perform the task that you will require. So essentially they're sitting on a similar platform, a similar thing, but it really depends on the goal you design. Okay. So don't be careful not to use the word experience to kind of go around and say, oh, I want to build application that give a good experience, but your application about collecting money. It wouldn't make sense, you see what I mean? The experience would always link themselves to really a positive impression after the use. And nobody use the bank apps and then feel happy to be paying bill. You see what I mean? So those what you would describe in the term of user interface. How people can perform their tasks, how accurate they can perform it, how many errors you've made, how often they do, and then how long it takes them. So some of these, as I think a little before, there's some technology, some display tracking, and some of the tool here, Unity allow you to do that. And this is what application design. So that's why this unit sit. And a lot of time you'll be looking at how people interact. Because remember, we are dealing with, in this context unit here, is a user interface. You can say, my application doing this. Human, requirement for human do nothing. Like machine learning. I bump the data into a big data cluster and just do a thing for me. That's not the project for this unit. Because this unit, human need to be in the loop. Yeah, so it's not like humans start the application and then they sip a coffee waiting for it to finish. And there's no user requirements. So in this case, you need to think about interaction. Okay. So that's what the one single constraint that you have. Just not application, but you need to be able to put a human in the loop application you're projecting, because the whole unit would center around human-computer interaction. Okay. So that's why some of these would just give you a quick highlight. Okay. On like medical, some of the applications here we'll go through. Some of this already talked about at the UNC. So ultrasonics, machine, Superman vision, see-through objects. Okay. This one is also done at Siemens. Okay. This one is stereoscopic. So this one back in New Jersey. So you can see here, this is a kind of high-pitched concept from Siemens Research. Siemens is a big company, medical, that build all this expensive medical device. So some of them is like, oh, if you X-ray, what happens if you can actually plan it before and then see, okay, where should I put, some knife or something into the patient? I need to plan that actually. I don't just chop off some important organ in the way. So this is kind of planning. Before they do planning anyway, doctor, but they're planning on a 2D projection, the slide or scan or something like that, and then they kind of use their best experience to go in. So they were projecting this kind of display will allow them to bypass those risks, okay, or mitigate them. Some of these is actually being projected much earlier, but nowadays big companies, auto company use this. Hopefully that, like you're driving a car now, if your car breaks down in the middle of a desert, then your best hope is, if you have no knowledge of your car at all, what to look for, your best knowledge is try to look for car manual, or whatever is if there or not, and you try to flip to these thousands of pages and try to find what to do. And this is what AR was supposed to do, is basically, what if you know what model of car you're looking at? Once you know that, just like you are an experienced mechanic, you will know precisely which part is which part. Like you're expert in this part of car, right? So you will know precisely where our things are. So the AR will be able to project it, okay, this is where certain part of the car is, this is what, and then maybe ask you a little bit of what the symptom, and then it will just guide you through it. But guiding you not just instruction-based, but it's actually observe how you do it, right? It's much, okay, this is step one, okay, you done it, step two, instead of you have to enter. So AR will become a kind of middle layer that allow you to do that. So that's what I think auto companies are hoping to get. Right now, they're not quite there. They're in the phase of manufacturing. What happens if you actually have smart glass, you see things that you can example before you do it. Yeah, so, but eventually we'll go into a maintenance stuff. Yeah. That's why in the future, I think most of your app will come, what car you're driving, you just load that app. Basically, you pop it up. It basically uses image recognition to recognize which part you're looking at, and use AR and spatial tracking to actually track its space. So while you're moving around, once you identify what car you're looking at, you can move around inside the hood, the top engine part, and it can tell you precisely, oh, you need to unplug this one, so it just gives you a 3D arrow inside that space, and it guides you there. So this is just kind of early concept. This one is a quite interesting work. This is by Basically, Blair McIntyre, he's now with Virginia Tech, but he's a postgrad at Columbia University, which is another center of AR system in the late 90s. So this one is actually CDOC machine. No problem this day. In my days, CDOC machine is the one that quite interesting because it keeps breaking down. And you have no way at all the things that we think we can do, we can't fix CDOC machine. So basically he's like, okay, I'm fed up with that, so I will just create a system that actually will teach others how to fix it. Okay, so he created a tray. Oh, why don't you, first thing you always know, you have to create a tray. So they have a wireframe tray. Pop up and say, okay, you put it here. So the system will guide them there. But of course, all this system requires fixed, very precise calibration of the space, where the machine is, where the whole thing is. So it needs to be alignments. Okay? So it's not the same. This capture image is quite handy to sell idea, which I think a lot of them will go in that direction. So this one is annotation. So this one oftentimes is what you use now. It's like a Google Map, but in 3D. Okay, I think that's coming online really soon. Yeah, so right now you have a GPS on the car. That's mostly 2D. They have a 3D perspection. But in this case, you could actually have a built into a windshield. Manufacturing companies are looking at this. Land Rovers are looking to put into this in play. There's some technical difficulty in doing so, but it's actually that's what they were looking. While driving a car, the whole thing was floating in front of you. Not floating, but it's kind of in the windshield with you. So this one is annotation. So that's what at the Hughes Research Lab that I was intern in 2000. They were doing outdoor for military AR. So like, you're zooming it out, the annotation pop up everywhere. So that's the landscape around Malibu in California. And this is at Columbia. So they do a first university tour using AR with the backpacks about 10 kilos. And you can walk around, very quite heavy. But if you want to graduate with PhD, then you have to do it, and you carry, and then you carry, and then collect data. So essentially here, the premise is very, very weak. It's like, first day open day, first day of university, you don't know where I reached, so why don't you wear out 15 kilo system, and then they will tell you where is the building, where is the library, where your lecture. But the concept is quite spot on. I think this is evolved later on into what the virtual tour is in Second Life. They used to do it 10, 15 years ago in virtual environments on the desktop, allow you to familiar with the space. But the premise is there. But at that time, during the prototype, duct tape prototype, the purpose of use, it doesn't have to be good because the whole bulk of focus is how to get the system to work. But now the focus is shifting because more people would not get to work on the technology enabling component. No more duct tape exercise because those big companies are pulling billions of dollars. So there's a top researcher working there. There's no point. The university like me or a student will mostly work on application now. Yeah, so we shift the focus. Okay, that's why this unit should be fine if you're actually not going to try to excel in a technical component. I'm not suggesting that if you want to, you cannot do it. You can still do it. In technical, you can do the technical side. Right, so the annotation is the key. So you can see here the premise is, all kind of blown around. We can pop it up. We can see many things. Of course, this flagged the privacy issues. Okay, like the funny joke around story around Google Glass when it first came out. It has a camera built in, so you can have a recording live as you walking around. So they thought, that's a good idea to be advertised as key, and then they forgot to turn it off. One guy forgot to turn it off when they go to toilet. And then the whole thing was like, okay, but we done this so good because it actually just captures everything. Yeah? So this one is actually one of those. So this guy, because social media, a lot of things. So this is kind of early idea. That actually doesn't go anywhere. Okay, people will say, it's a good idea to hold a phone like this and look around and just keep holding it. 30 minutes later, you're still holding it. So essentially, what you find is that it's very fatigued for the interface components. Is a very poor design. Yeah, so that Google Glass, the form factors are quite there, but actually the ethical issues is still privacy. Okay, so the privacy technical issues, why would you want to know, what the face is? But right now with the deep learning running all this, AI is very much be a medium to display. So a lot of big data collecting, it doesn't matter how common people like us complain. Government, if they have enough money, big company, they're practically already done it. Yeah, you just complain outside looking in. you just complain it. But I think the ability to track your individual face is now coming online. Okay, I think it's the other day I seen in China, is they're doing that. Okay, they track the way, not just the way your face look, the way you walk. And that's it actually they provide, that's evidence of the more accurate. So now you're walking in open space, then I think the chance that you're getting more track of what you're doing. So I think, yes, for the better for good, we're just well aware of them. Okay. See how many sizes. Okay, so maybe I have a break here, so 5 minutes. So let's say 10:05. Okay, come back. All right, so I just have to make sure that I remember to turn on the mic. Okay. All right, so this is one of our early work. You know, the HIT Lab has HIT Lab in New Zealand, which is in Christchurch, University of Canterbury. So they do a lot of this. So that's what Mark Billinghurst set up the lab in 2002. So he took his technology AR toolkit with a little Japanese character and moved that technology in the HIT Lab. And then the first 5 to 10 years of HIT Lab New Zealand is really spin off a lot of, you can see this marker. That's his signature. If you see this marker, most likely that paper either have him involved or cite his work. So that's practically almost guarantee. And there's I think over 10,000 papers like that. Okay, so that's why he's a very famous. Okay, and so this is some of his project. Okay, so interactive museum. So people come in instead of head mouse. So he come up with well, we have a stick that actually instead of wrapped around it, you have a stick like a magic wand that you kind of look through it, so you can see here. It's a very subtle change, but if you think about it in terms of usability, this is quite effective. Put the people on the head, just like Oculus, that's just a good example. It's a really awkward experience. In fact, the VR was never looking cool until the last few years when Oculus started to take off. Before that, it was like, if you go in with a new people, visit a lab, like HIT Lab in the US, whoa, the 3 guests come in, or a number of guests come in, and please try the VR headset on. No one would put their hands up first. One of the problems is that, you know what the concern for that? Well, why would they reluctant? Why now it's less so? Like yesterday, I think I don't get a sense that anyone kind of, there's a few people that try to not to be in it, but most people will feel okay to get in them. But why would the technology then was what the holding people up and putting head mounts?
You're making it look silly.
Yes, that's unless you believe that you're already looking silly. So usually people say, "Oh no, it's probably not a good idea to be laughed at because when I'm in there and I'm probably looking ugly." Because when they take a picture, it's not looking cool like now that the headset I showed you before. It's looking very, very awkward. And then basically, and oftentimes people will told them that in VR will cause you sick. And then people will say, oh, maybe you go first. And those have become sort of, because when in the VR you experienced yesterday, is that if you're having fun, it's okay. But if you're not having fun and people will keep laughing at you, I mean, that's practically a very awkward experience, unless you design for that, but it's actually usually people will avoid that. Yes, so this one is kind of hand in museum. Instead of strap everything on, you have someone to do this. This one is just like hanging there. If you want to look, you just grab it and then you just look around. So there's a museum, there's a music component. Anything that you see here has augmented components. So I mean, all the cards here will play a different tone. So in this case, I think it's a solar system. So they move things around. So in AR, once you use that as a tracking component, the rest of it is really just about your application design, what it's for. Right, so this one is volcano, planet, and they're all based on the same technology. That's what the last thing I asked for assignment 1 is a potential application. It's the same thing. If you find something in application in museum, you say, oh, this technology could apply to education. That's what I was looking for. Yeah, so that's kind of simple things that is the core same technology. Okay. I think this part I'll quickly cover this. So like this one is the augmented one, the speed, because you can't really have the speed fixed. Because the pitch, this is a baseball, so you pitch, and they measure the speed in which the pitch is going. So that one had to change all the time, okay? So instead of you have a big display there, and then it immediately got hit by this pitch, so you just have an augmented view. Of course, the flip side for this one is that the real audience who actually sit nearby won't see it. They actually, what they have to do, they have to look up at the big screen on the stadium and say, oh, that's 83. Yeah, so, but that in the television audience will see that. Okay. And that one we'll talk about that. This one is a bit in education. They will say, oh, this would help learning. This is still ongoing. One of my papers a few years ago addressed some of these. This is not my work, but I did with education desk. This is about education area, because this is when people start to realize, because this is simple enough for kids to do. Kid doesn't mind all this black border, it just looks like a toy to them, right? So it's in terms of acceptance, it's extremely high. It's not really commercial or looking like a productivity. So it's kind of find a natural fit inside the education context, okay? So they will put out different marker, different character. If you put them together, they interact differently. So that's a message that educators try to send to students. So that's what they play with. This is what I think example is a good one, is that they understand technology a little bit, but then the key part here is how to design application, just that particular application, that particular current state of the art or technology then can deliver, not design something that you're not yet ready technically. Okay, so that's why this is one of the good examples there. Okay, of course, all this is looking. The high goal for this one is not just so the kids can play games. It's more or less what it has impact on the learning. That's a lot of what VR project is in and AR is in now. It's not just to make it happen, because no longer it's not in the hands of most people. Big company, Facebook, Microsoft are pushing that. Let's make it happen. But then how do you use it? And that's why a lot of you, one of you could turn out to be a billionaire in the future if you got this one right. Hopefully you don't forget me when you got rich. Yeah, so. And this one is just kind of high concept that people think, oh, wow, we go to the place we're no longer there. 2,000 years ago, we want to see what million people, the image on the left top here is actually how people in the old days are cooking. So my wife was strapped a 5-kilo system and walking around with AR. Something like that, so then it's go like this. So of course he's a researcher in the team, otherwise he wouldn't be in the picture. So that means that this is a really concept pitch, okay? But the technology is just like duct tape I said before. Most of them is just try to get the system to work. Yes, so, but you can, when you read through this paper, you don't just look at how technology that behind from today, you just simply pick the idea why we try to do that, and whether actually we can do better now. I mean, that's the whole thing. Yeah. And this one is actually one that actually make it to the actual store inside Lego. Okay, I think this one would need to click and place. Just give me a second. Apparently the link doesn't work. Just give me a second. So you don't have to worry about the sound. It's kids playing Lego. So you've been to Lego stores, so they're like this. So you pop up inside a kind of kiosk. It tells you the model. Instead, you just look out of the box, it tells you the model. So the kids now are rotating around to see whether the model is what they want to buy. So this is the one that, not a duct tape prototype. This is the one that make to the actual store. Yes, but this is like 10 years ago. It still should have it now. So, and by now it should just be an app that developed by them. Open the app and just look whatever the product. Yeah, I'm not sure if students actually interested more on the AR component or the actual product. So it'd be interesting to see how many of them are buying them, or they just come and play with this one. But either way, if it doesn't turn into a dollar sign, it at least turn into a good experience. I mean, one way is someone with company with cash can afford that. Okay, so this is one, what we have here. We don't have Meta 2. We almost got one, but I have to cancel because I think the review is not so good. HoloLens is the one we have, so we'll get a chance to play with them either tomorrow or early next week. But anyone, yes, so those, we have a couple of those, 2 of them, so, but they are very super expensive. This one we have BT200s. This one is, they're all slightly, Meta 2 and HoloLens is something that kind of in the same ballpark. Optical see-through, you can see through the real world. You can see through the glass that you can see here. If there's someone wear it, you can see their eyes. Okay, and the projection is come from the top. Okay, it's kind of projected from the micro projector on the top. So HoloLens would have a multi-grade lens in front of them. Yeah, you will see it in the first hand. They are fully field-built. The difference here is that field of view of that is only less than 40 degrees. So I mean, it's about this. When you wear them, you still see everything else, but your virtual content is only limited within that small window. So let's say you want to look at the object, the size of bigger the room, you can still see it, but you only see that one part at one time. So you just have to feel like you're sliding through this content. Unlike the VR, which is have about 110 degrees, so you practically see almost everything. Yes, so what that means is that it affects how your head movements move. You end up moving a lot more than what you actually need to. Yeah. And And Meta 2 is actually one of the selling point, and this one is, I think they're about, I think they should release, it's about field of view. I think this is the one that claimed they're pushing about 100 degrees. I think the 90, I think that's what they were getting. But their tracking was so bad that actually I tried on. The objects are floating around like in mid-2000 technology. I said, okay, so how are we going to go with this? And the key part here, HoloLens, is fully built. So I mean, you charge, just like mobile device, it's stuck and you just walk. Okay, I don't run, you can walk, yes. But Meta has a computer, everything attached to it. So I mean, they're very, very different ball game. But of course, that's $1,000. That's almost $5,000. Okay. This one is different. This one is not an AR device. It's a head-up display. Essentially, projection into here. You can see very clearly. But then everything, those things is Android control. Okay, so you can control the part, objects, and things like that. It's a practically Android device. It just has the display on it. This one has a very good use in the functional use, like when you go to construction, you're looking at the work that actually the one is clear, but you don't need any stabilization. You don't need to put a virtual object into the cup or anything. Okay, so that is probably good for that. And this one, less than $1,000, so it's still expensive, but it's good. Yeah. All right, so AR here. Okay, so try to see you can grant to this. His writing style is not conventional academic, so it's easy to read, easier to read. Okay, so you should find this. What he writes is actually quite easy to go through them. Okay. All right, so any question on AR? As I say during off sessions, this week is about lay out some history work. Okay, so people, you kind of get the basic idea, because by now you should be going out and look at whatever available there. So most of you will see something that's mostly new than this. Okay, but that is actually allow you to bridge between what the foundation, what it's coming from, in terms of this, because this is really not about learning what is here. It's about learning what's been here, how it get here as well, to help you build what the future might be. Okay, next week I'll be updating more contents that more kind of latest one. So now the next one, okay, is this one involved class exercise. If we can get to that part. This one, remember the diagram we have before. This is on the design process. Okay, some of you will find that this one is actually something that kind of give you more room to play, rather than have to learn a whole bunch of programming to do something. And this one actually can get off, and then you can think about it and do something about that. So in 3D interaction, as I said before, this is recite what I had before. So the key here is a real interaction. Application in this space is really centered around what human can do. And of course, human, if you're inside a different field, they call brain-computer interactions. So in that case, what people do could just be in your head. A lot of straps thrown around your head. But we're not there yet. Okay? So we're still visual interaction style. So that means oftentimes, when we mean interaction, it doesn't just mean you dream and it happens. What it means is that how your hands move, what to push, how to do, procedure-based. So this is more active, progressive action, interaction. So as I said before, how do you design a button, what the function is supposed to do, what is supposed to do, what human need to do, interact. Okay, so that's what I think that's what we focus on. Okay. So this one, interaction task here. Oh, actually, I think did I get the wrong slide on? Yeah, I think I got the one. I screwed up on the folder. That's why it doesn't feel right. And we're talking interaction, didn't I? All right, so sorry about that. So this is one that we have from yesterday. Okay, so this is what I was talking about, the purple bridge. Okay, about merging between technology and experience. Okay, so this is a kind of what we have yesterday. So what we actually try to see here is, then how will you go about that? Well, you know, okay, it's bridge, but how is there any framework? So that's what the rest of today's lecture was about. Okay, what is the design? What is how you go about this? Basically it's a guidelines. It's really not a set in stone. There's no guarantee that you have to do this, but this should be the proven that actually it works before. Okay. There's no guarantee that it will get you a billionaire, but it's kind of worked in this step before. It's centered around fusion between this is what Tom Furness was finding and then refined on top of that. It's actually get the iterative design, which is actually you design, you're testing with the user, and you revise them like a loop. Okay, so this is you will see that this step, if you go look quickly to it, it's a step is like that. Okay, the first 4 steps is really something that build your foundation of your design. Okay, so that's how we'll go to a few steps of this for today. So we cover the first 4. So identify user need. This is where students sometimes get confused. Usually they misinterpret that what user need to do. Okay, in this case, is really the need is that what's the difficulty, what their current problems are, and what is difficult at the moment. Okay, that's what they need. Like you need for money, you need for graduate, you need for something like that. So what's the difficult part? Okay, so this one is linked to the lecture. Okay, from a couple of days ago on the magic map. So this I highlight some of these. You can go back and review those. So I try to map both of them so you can see the different stage. So it's hopefully give you a guideline leading up to next week's assignment 2. Okay. So this one, okay. So once you identify this, so you have, of course, you have to pick a problem. In assignment 2, you don't actually have no restriction. You can pick anything. Just like assignment 1, you can pick anything to work on. Okay. So in this case, the difficult part is that the problem. Some people would have a slow starter. They might have some problem with what should I do? What should I do? And then when they have 5 hours, then yeah, I know now what I need to do because I have 5 hours to go. And then usually this is usually when you kind of not really get started very early. That's usually what you happen. But if you read around, doing around home, and then you will kind of get idea. Oh, I pick one because this is very flexible in terms of what you want to do. So. But sometimes it can be difficult for some students because flexible means too much flexibility and not know what to do. You're used to being told what to do and things. Yes, this is a little bit different. So then you will go on to this step. The next step is determine requirements for the interface. Okay, so in this case, like Magic Map, you would okay, this is what you have to hit. You have to create a user experience. You have to create an intuitive interface that's different than a web-based that they've been using. Some of those. So as you can see here, the technology is not identified at this stage. Only the problem in the first, and now is actually what should be approaching. This should be only the approach requirement from the interface size consideration. As I said before, my example, like if your bandwidth is slow, internet is slow, then you not necessarily say, interface design is to increase bandwidth the speed of NBN or something like that. It's nothing to do with interface. Yeah, so in this case, that's what you should be looking into that space. Okay. Then once you have that, then you kind of going around and select technology. This is oftentimes the case when people already know. Like in this case, I can admit, I already know what I'm going to land, but I pretend that I don't know. But in fact, and most of the students make the same mistake, is that actually they already know what they want. They just build a story backward. It's step 1, step 2, there's no technology involved. Yes, there's no per se, you just need to stay within domain, that's all you do. In fact, it's best that way. Okay. Even though in the end you might end up with best technology to do a projection-based system, but by the way we don't have that in the tutorial, so then I have to go back and change. So in some way you will find yourself kind of going back and forth between the step 3 and really step 1, or like, what I can do with Riff, and then you kind of go backward and say, okay, this is a problem. Is this a realistic problem? And then you kind of go that in a loop. This is probably, and then you start with step 1 and define need, and then you go to, it could fit. You could have a requirement interface like this, and you build it. Some of the cases that are, this one could be used for, bungee jump or something like that, and then you go back, the first step, try to build it, and then you realize that, probably safety concern is not good. So you go around and around until you find a good match between what you think you want to play and what you want actually the problem to solve. Okay. But ideally, you would actually start with step 1 that actually we understand, because one of the problems with this one is that if you have fixes on the problem, not the problem, the solution too much, it's cave, this one. You basically just make this one like made for that device, and it's really obvious in terms of design that actually it's really not designed for application. It's really designed to showcase what you can do with the device, which is a lot of demo you see on YouTube is like that. They were just designed to showcase what they can do, but really not what it can be used for. Okay, so in your case, you have to try to balance that so that you get a more sweet spot. Okay, so in this case, the step here, once you have that, this is going to a bit of interaction design. So this is stores, you're familiar with storyboarding a little bit. So this is a projection use case. Okay, so for example, once you get to this stage, okay, you say, oh, I'll use augmented reality. I'll use tangible user interface. But then now you have to say, okay, what function do I have to do? What is a TUI or tangible user interface for? Okay, what's suitable to fit into those? Right, so you would think about these circumstances. And that's what this step 4 is, which is a storyboarding of the whole content. Storyboarding here is projecting the use of the application you're proposing to do. How is it used? And also, secondary, to use to showcase what it can do. So this is like, this is one from our master student that did a project before, a few years ago. You would design a mobile app that actually location-based indoor. Okay, he's not building the system. He has this what they call iBeacon, which is a little small NPC device by Apple. Okay, when your device your mobile go, if you turn on the apps, and it will show you, okay, you go to this sensor, it will send you a push message. Yeah, but there are sensors everywhere, so he just stick that sensor around the building, and just to tell people, okay, this is in your office, this is a toilet, and then he tried to say, okay, how do we actually use this application that he's developing to guide the indoor? Okay, so in that case, he will play with the actual screen design of what the apps look like. So you can see here his projection case here. You're walking here, then the sound happen, and what has sound happened, what is appear on the screen, things like that. So he will project in that case. Okay, and you can see here the different scenario here. So generally, just like I wouldn't say 24 hours of life, but I would say more or less in the case. Let's say your apps is only good for when purchasing something, then you will describe them at the beginning, before you're using. Just before you start the app, after you use the app, during using the app, and finish the app. So the kind of life cycle of that. If that's mean 5 minutes, then that's what the 5 minutes of storyboarding would be. If the app is about getting you healthy, waking up, warning you how to go to bed and things like that, then your storyboard will cover the whole range of the one cycle. Okay, it doesn't have to be snapshot. Every single minute. Snapshot. This one for group project. You would expect to do this quite a bit, a couple of pages, maybe you have 4 or 5 scenarios that you projected. For your assignment 2, most likely you have 1 or 2, or maybe 1, because you're only a single person, and you would probably just do a very small, tiny bit. Okay, so but that's it. Just what it could. I think that would look like. So this one would allow you and your team to actually translate the idea. Is this how we see the application being used? Because this is where people really get creative and also really get a very critical review. So that means if it doesn't something's odd, like some situation is odd, it could actually pinpoint back to the process of what maybe you're selecting the wrong technology, or maybe we find something else. Is that could we do better? Yeah, so that's the kind of feedback into the loops here. So the design process here is a step, but it's actually nothing prevent you to go backward and revise them in the process. Okay, that might actually addressing here all the way up here. If your storyboard is strong, it will actually tell you. In fact, you don't actually need AR. You can actually need a good direction apps, something like that. You might just address to this problem. It's actually, in fact, this is a make-up problem. It's not actually realistic. So when you look in the storyboarding, it looks very weak. Like, oh, yeah, it's good to show, but it's really not strong. So you actually could come back here. Okay. So, and one of these things is that in your assignment 3, when you do a group project, you have less time, but you have more people. So that means that the journey in which you go to this step, we should just point out the whole thing here. We just covered the first top 4. You could go back and forth. Okay? You don't actually have to stuck on one thing. Let's say you discover something, take you backward. You can recognize, you can journal this, you can actually record that, report that as part of progress. This is you've never been to a design progress course before. It's basically a journey of design. Okay, so when you record this, how you run into a problem, you go back and solve. But in your case here, since you don't have time to deal with the actual difficult problem, most likely you probably don't need to go through back and forth. You usually go straight and finish. Okay, so the part that I didn't quite cover is the 5, 6, and 7, and that's practically inside the small developments for the assignment 2. 5, 6, 7, 6 probably doesn't exist for you. 7 is impossible. In fact, 6 and 7, 7 is probably not possible for the whole unit, because I think that means you require you to redesign and then come back and redo again when you double the project length, essentially, if not more. But you probably could get in assignment 3 with the group work to get the preliminary evaluation. Okay, and that could mean half an hour. What I mean, you just get the other group to test on what you're doing and get their comments, and that's it. Whether the comments could be, "Oh, your app is so bad," how bad they are, things like, it doesn't really matter. Okay, I mean, it's just a feedback. It's a user feedback, and it's, on the other hand, if they say, "Oh, yours is very good, it's very cool," it doesn't mean anything in terms of marking. It just means, okay, you collect the data. Okay. In fact, the more they praise about you, or the question I have in my mind, well, you have 2-3 days, how far can you do with this? And then you realize, okay, so they're just all good. Because essentially you take turn. That's one of the bias in the evaluation. Well, I won't say bad thing about you, so you just don't say bad thing about me. Yeah, I think it's everything go around. But number 5 here, you would get to, at one point, I was hoping that you expected to get the 82 that you do next Wednesday, to at least get something to working. Right? Even though it's very primitive. That's why this afternoon, today's tutorials is about picking back different projects that Oculus frameworks are introducing. There's a lot of examples that you can grab and copy that you can use for your things. You just need time to a little bit understand what to grab, what to not grab, what important, what driving which one. That's it. You're not required to build the code from scratch. Okay, but it doesn't matter. But nothing prevents you from building from scratch. If you want to, you can still do it. Yeah. But just have to make sure you submit on time. All right. So I think we have about 15 minutes, but probably not enough for this session here. So generally what I'll do here is I'll run a group of 3 or 4 inside the class, okay, and I'll give you some topic from the list that I'll show you, but I think we only have 15 minutes, so it won't be enough time. So this one will be kind of in exercise that you kind of go through the first 4 steps that I just described to you, giving a topic that you've been giving a list. This one, probably you need to do this at home or try to think along. And then basically you give up, stand up, and then you talk a little bit back to the class, okay. That's why it generally takes about 40-45 minutes. Okay. So topics, some of these you will see some example here. So I think the library books I show in the first day assignment, first day of lecture from previous many years ago project. Physical therapy, this is one of my projects. If you look at my publication, it's called Ghostman, so the Oham of those. So you can take a look at those papers. And then chemistry, this is also one of our papers. It's called Moly-Poly on my paper list. So that will publish. So this one is for chemistry learnings by organics learning. They have multiple ball color, carbon, hydrogen, oxygen, how to build them, what is the organic structure look like in 3D. So we use the leaf motion to build for this one. Yeah, but you can think about what, if this is a problem you start with, how would you create a project? Yes, very simple like that. Okay. So maybe we have a few minutes here. You want to have a crack? Which one you think is interesting for you? This will go from blank to blank to blank. Yeah. Or any other topics that you might be interested in. Because this will be useful for this lecture for you to get to think about, oh, okay, what is a design process look like? This is try to aim for you to get the exercise for it. Because this is, most of your unit here are probably not like this. Okay? Most of unit in MITS and BICT, they're more information system, I cannot say too much about it, but in more computing-based or more instruction or more procedure-based what to do and what to achieve, the goal clearly defined. This one is actually, students find in the past it's hard to define their own goals, define their own problem domains. And another problem they find, which is a good one to find, is that they know what to do, but my job is try to contain them within what they can do. Because otherwise they end up, I want to do this big, but in fact you can only probably do this because your time is about to run out. So other ways are good learning experience in those components. So how about in the bookstore, book sorting? So when you need 5, you basically, what it does is that it's going to mean that you read some paper about what the difficulty are, or you actually go to the bookstore, to the library, talk to librarians, what the difficulty. Let's say this is what they tell them. It's very difficult to find a shelf location where people return books. Okay. Well, by the way, when the last time you at the library? Yeah. No, okay, same. Okay. So let's just assume that this is a problem. Yeah, it might not be having a book to return anymore. So because they're now all digital and everything. Figured out a shelf location, and that's a basic. This could apply to, big warehouse storage, like Amazon, or, all those big companies, shipping company now is using more autonomous robot. Okay, so they kind of go boop, 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 moving, and you should find the video very, very interesting when the army of robot, which just kind of take from one shelf, go to the other one, boop, 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 boop. Yeah, so that one is actually, those wouldn't classify for us to do for this context because humans is really not in the loop. But for these, it's a traditional. And you have a book, 20 of them, and you have 5-story of library building. Which one go, which one, things like that. And once you get to the shelf, where exactly is it? You have to light up, look at the size, bar, and then try to find each one of them. And that's why it's a little bit of promise on, okay, what happens if you have a small device enough that you can just see through them and say, okay, that's where is this? And you have a 3D arrow kind of pointed in that space. Yes, so those are kind of basic components there. But this one could be spun into a more training inside VR environment. What happens if the AR is not yet mature enough to operate in that space? Let's say you cannot tell precisely, you can only tell where the AR is. What happens if you just want the VR to train them? Can you read this? Can you tell this? Things like that. That could be another spin, but that is a very weak justification because it's that training would have to consider some cost effect to it. How easy is it for you to train on a real shelf compared to you build a VR to test the same thing? In the medical, it makes sense. It's a cost, the casualty of mistakes has a significant consequence. In the shelf, you put in the wrong shelf, probably not a good idea, but it's probably, that's okay too. Probably not as bad. So, building a simulation, it doesn't really, to me, it doesn't really, okay, yeah, it's good for project, but probably not that strong justified. But just want to say, so it actually, you can spin like this, one idea. In fact, since we have many, 85 students, assignment 2, I expect some idea to kind of sit on top of one another. But what I expect is that 85, not single one of them actually come up with the same solution on the same problem, because essentially it's the same project. Okay, so you could be talking to your friend, your peer, but at the same time, working the same problem, but working on a different solution. That's perfectly fine. But of course, the writing cannot be the same, because that's where the system now can very easily detect. When you submit to Milo, I can compare between one student versus the other 84. I can tell you paragraph by paragraph how you actually copy. Yeah, so if you're going to copy and modify it, you end up having to do a lot to escape those kind of detection system, because one is flagged, there's nothing I can do. One is flagged, I have to address them, and one I detect that it's actually there's a illegal copy. I need to report it to the school. I'm not in charge of that component, so it will be out of my hand automatically. Okay. So my advice: not do that. don't attempt to do that. I think you'll be all good. Yeah. All right. So I think we have finished early. Any questions? Okay. Okay. Look like everyone is on the gear 1 now. Try to go. Look like I'm holding you back or something.